Let's do our usual hardware walk around. This one's going to be a lot more complex because there's a lot more things going on, but I'll try to show as much detail as I can. Let's just start with the pi, and we'll look at the pins. We'll start with pin number 1. Pin number 1 is 3 volts out, and we're going to use that to power the LED, and this would also power the output. So like you're going to open a solenoid, turn on a light, something like that, this will be the place where it comes from. This will be the 5 volt power supply. This will go into our voltage divider. It must go into the voltage divider, otherwise you'll ruin your Pi. It is going to be the power for the water meter. Moving on over here, this is pin 9. Sometimes I use pin 6, but in this case I use pin 9. It's just a ground. All the grounds are the same. This is pin 11. Pin 11 is going to be our activation switch. So if you're going to use this for a, say for a drip system, watering, something like this, this might be your dry sensor, your wet and dry sensor. So on to 1113, the yellow wire is 13. It's coming back from our voltage divider, it's from our water meter. And then this last one over here is pin 15, and pin 15 is going to be the, this would be the output to your solenoid, so that it would turn on and off your solenoid, something like that, whatever you're going to activate. So what we have again is this is the, if you will, the input to the Pi that's going to signal it to do something. This is going to be the meter, which is going to measure what's going on. And then the last one over here is the result, and this will be the output, if you will. So this will turn on and off, say, a water solenoid. So those are the pins on the Pi. Now let's trace these wires over to the breakout board, which is here. You can see they all come over the same colors. Let's start with the 3 volts from the Pi. That's this one. We just plugged it into our power bus, into the positive. You can see the positive there, into the power bus. And it's going to power some of the other things down the road. The yellow wire, which was pin 13, is this one right here. So it's the voltage divider. It's the one going back to the Pi that's going to tell it, in this case, the water meter. This other yellow wire that I'm touching now is going to the plug back there in the background. You can see it goes to the plug, it goes to the water meter, which we'll get to in a second. And then this side is the ground. This is the ground from the Pi. This is the ground to the water meter. This is our voltage divider circuit. This is our 4.7K ohm resistor. This is our 10K ohm resistor. Let's move on around. Kind of a jungle of wires in here. We'll do our best to show it off. I'll get these out of the way. We'll move the... Okay. This is the orange wire from the Pi back here, and it is going to pin 15, and all it's going to do is it's going to turn on our LED, and our LED goes through a, usually it's like a 330 ohm resistor, something like that. I think I've got a little bit more on it than that, but something to keep the full load of the full current from going back to the Pi. And all this is going to be, this represents our, say, a water solenoid, if you're going to open a water valve, something like that. So we'll be able to see this turn on when the water valve would be open. And then on this side, it just goes back to the ground. You can see over here. And finally, this last thing, this represents our water sensor, if you will, or it could be a switch. So let's say you were going to fill a cattle tank or something, and you wanted to know how many liters of water were going into your cattle tank. This would be the valve, so you'd have a float switch in there. This would go to the float switch, or if you're doing irrigation, drip system, something like this, this would be your wet-dry sensor. So what I'm going to do during the demonstration is I'm going to move this back and forth between here and here for on and off. On this side it will be off, and on this side it will be on. I almost forgot. This is our water meter. You can see the impeller down inside there, and this is the same as from my other videos. You can see the direction of water flow, and not much to it. There's just an impeller. It's on a shaft. It's got a magnet. It's got a Hall effect switch back in here, and when the impeller spins around, it sends pulses down these wires. The Pi is going to record those pulses and translate that into liters of water. So that's our whole system. Now let's go look and see what the software does, and we'll go step by step through the software and see how it all works. Let's look at the code behind our software here. This is written for Python 3. I'm using the YFS201 flow meter, and I've got several videos on that. If you have, you might be interested in looking at those. We're going to use polling as opposed to interrupts. There's going to be an on-off based option. So for example, if you're filling a stock tank, you may want a float switch, or you may want a wet-dry sensor, which is the application that I've written for. This does check for stop flow. One of the problems with a meter is when the meter stops, sometimes it gives fake readings. So this does check for stop flow. The output is approximate because the meter has limitations on the high and low end. The input will be pin 13. It has to go through a voltage divider. These three lines right here are to remind me to run that through a voltage divider, because if you take that 5 volts that the meter needs and you run it back to the Pi without a voltage divider, you will kill your Pi. Down here is pin 11 will be the moisture sensor. Pin 15 will be the water valve control. This water valve control would be, for example, a solid state relay, and I've got a video on how to do that. Then we're going to import the GPIO because we need to use the pins, so we need that library. We're going to import the time and system functions because we're going to need those. Let's scroll down. We're going to set the GPIO pins to board mode. The wet-dry sensor will be on pin 11. We're going to set that to input. The meter is going to be on pin 13. You can see here. It's also an input, and the water valve control is going to be set up as an output, and that's because, again, that'll be controlling our solenoid or water valve. These are some variables I use in the program. Times, the rate counter is to report on the liters per minute. This constant is something you'll have to experiment with your meter and determine how many liters per minute it is and set that accordingly. So that's how you calibrate the meter right there. This last one, the report interval, allows you to set how often the program reports back to you. This is set for 10 seconds. Obviously that's too often, but if you set it for 5 minutes or 20 minutes or something like that, we'd have to sit here during the demonstration for that long to see it working. So I've done a few cheats in the program in order to make it report so that we can see it happen in real time on the camera. Then we get down to the meat of the program. We actually start executing stuff. We're going to print out water flow. This is an approximate estimation of how much water, because again, the meter is not always accurate. We have a Control C to exit nicely, so that when you press Control C, it will exit the program nicely instead of just smashing its way out. The first thing we're going to do is we're going to capture the beginning time so we know how long the system has been operating. And this try statement, we have a try, and then down here we have an accept, and this is what allows us to exit the program nicely when we do the Control C. So that first statement is the try. This loop, this is probably the most important thing, this while loop. It goes from here down to this rate count. And let's go through this. So this is a perpetual loop. And the first thing we do is capture the current condition of the GPIO, the meter, and then we ask if the input, the dry sensor, the wet-dry sensor, is true, then we're going to turn the water on. So we're going to set the water valve to turn on. and then we're going to have a message that says sensor equals dry, valve equals open. So this is what's going to report to us on the screen. If the GPIO current condition is not equal to 0 and the GPIO current condition is not equal to the GPIO last, in other words, we're checking to see that the water meter is turning. So this is one of the statements that keeps us from having false reports if the water meter is stopped. We're going to increment our rate counter by 1 and our total counter by 1. Now this particular meter that I'm using sends 6 pulses per revolution, so I'm going to have to compensate for that later on. But this is actually 1/6 of a revolution every time it increments this. Okay, then the total counter, and then we're going to store the GPIO last condition from the current condition. We're going to keep this current condition, we're going to put it in what I call last, and that is again to ensure that the meter is moving. Otherwise, what we're going to do is we're going to turn the water valve off, and then we're going to print the message that says sensor equals wet, water valve is closed. Okay, let's go down here a little bit more. At this statement, the if time report, this is our reporting interval. So right now it's set to 10 seconds. So if there's a 10-second or more difference between the current time and our time report, then we're going to print this out. This statement, this /n plus valve, this is the valve it's going to print out. So it's going to print out one of those two messages, sensors wet, sensors dry, valve open, valve closed. It's going to print that here. Then we're going to print liters per minute, and then this is our liters per minute calculation, our rate count times that constant divided by the report. And then we're going to round it off to 2, and then we're going to remind people it's approximate. Then we're going to print the total liters, and that's our total count, again times the constant. We're going to print the time that's happened, so the total time, the local time, and so forth. And then we're going to set our rate count back to 0. We're going to repeat that loop over and over again, and if someone hits the Control C, it's going to come down here and it's going to do the exception. It's going to exit nicely. It's going to do the GPIO cleanup, print done, and then do a system exit.
Before we look at what our software is doing, let's take a look at what I'm going to be doing here off camera. I'm going to be moving this jumper back and forth. Right now you can see the LED is on, and when I move it over here, this turns the LED off. This white wire would represent our float switch, or for example our wet-dry sensor, and the LED will represent our solid-state relay, whether it's on or not. And we'll be able to see that in the software. We'll see it valve open, valve closed, and valve open, valve closed will be the LED either on or off, and then of course that relates to this jumper. Okay, so let's go operate the software and see what it does for us.
We'll start out with the sensor is wet, the valve is closed. That means the LED is off. The liters per minute is 0. The total liters is 0. And the total time the system is running is 0. And here is the wall clock. The same again, except now we've moved approximately 10 seconds. And this will report about every 10 seconds, which is, too much really. But for this demonstration, we wouldn't want to sit here and wait minutes between each report. So our valve is closed. Now I'm going to open the valve. I'm going to activate the switch, and you can see that the sensor went from wet to dry, and the valve is from closed to open. And let me blow some air through our meter to simulate water flowing. So here you can see it starting up. Here it's running at about as fast as I was blowing in it. The total amount of liters that have gone, now it's slowing down because I quit blowing through it, and now it's stopped altogether. And the total liters is staying the same. The total time is increasing, the wall clock is increasing, and that's it. When we want to stop it, we can stop it nicely with a Control C. You can see down here, exiting nicely, and that's it. Okay, well, that's the demonstration for this water control system. I hope you found it useful and interesting in your Raspberry Pi experimentation.